Hi, in this quick start video, I am presenting Setl, an integrated platform for semantic business intelligence that bridges semantic web and business intelligence technologies. Here, you will be looking how to use Setl to build a semantic data warehouse and apply OLAP queries on it. In this demonstration, we use the population dataset as a use case. The population cube is composed of three dimensions: living position dimensions, residence dimensions, and geographic dimensions, and only one measure, and it is number of population. The levels of each dimension are organized in different hierarchies. Our task is to design the T-box of the semantic data warehouse, next creating a box for the semantic data warehouse, and then apply OLAP queries on it. As you see here, Setl is organized into three layers: definition layer, ETL layer, and OLAP layer. User can create a new target T-box or edit the existing one by clicking here. Let's see how to create a new one. Click New T-box button and type a name, choose the format and directory to be saved. Very common prefixes are written by default. You can create new IRI or edit the existing one by clicking here, for example. The leftmost panel allows you to create different OWL and data warehouse construct, that means multi-dimensional constructs. Let's create a dimension. Select IRI, type dimension name and the level of the dimension. Then create a measure. Select prefix, type name and level of the measure. Click OK. Then create a cube. Select IRI, type cube name, add measures from the measure list. In this moment we have only one measure. Then add the aggregate function, add measure component, add dimensions from the dimensions list. Click OK. In this way, we can create different constructs. The corresponding triples for the constructs are generated internally and shown in the middle panel. You can save it now. Now let's open the target T-box we explained in our use case. Here we can see different multi-dimensional constructs, dimensions, hierarchies, level, attributes, cube, and cuboid. We can also add new construct or edit it. The rightmost panel shows the description of the selected construct, and it also allows adding and editing the components of the construct. For example, if we want to change the range of the level attributes we selected in the leftmost panel, we can do it by clicking update button and selecting desired values. Once a target is defined, the next task is to map between the sources and the target. You can select source and target files. To be mapped. The first task is to create a mapping dataset. Therefore, each source and target pair will be a dataset. Under a dataset, you can create concept mapping. Let's map between the target cuboid dataset and source facts concept. Select the relationship between them. Now the instance level mapping. You can select whether all instances of the source concept should be mapped or a subset of the instances. How to create the values for the IRS of the target instances. It can be a source property or same as source instance, incremental, or an expression. Here we want to create the expression of the source concept. The properties of source concepts. The next task is to map in property level. Here we can choose under which concept mapper the property mapper will be created. We can choose target property. The values of the target property can either be same values of source property or it can be an expression. Now we can save it. The corresponding triples for the mappings can be shown in the mapping file editor. The mapping can also be used for intermediate mappings. Intermediate mappings is used for the transformation on RDF literals. Let's open the mapping file of our use case. Here is the mapping file of our use case. You can see the different components of the file in the leftmost panel. The rightmost panel allows to edit the components. Once mapping is done, we can create an ETL flow. To populate the target T-box, we can create a new ETL from File menu. The left-hand side is showing all operators. It includes operation for extracting data from semantic and non-semantic sources. RDF wrapper, it converts non-semantic to RDF. T-box deriver, derive T-box from non-semantic sources. T-box from RDF abox. Instance generator, level entry generator, fact entry generator, update dimensional construct. It addresses the slowly changing dimension issues. And load operators is used to load data into a triple store. You can drag and drop the operators into the panel, into the ETL panel, in middle panel. Control flow is used to connect the operators. In the paper, we showed how the operations are connected using an ontology. Let me show you one example how it works with level entry fact entry generator. The input can either be a CSV or RDF. The path of the source file. Select the mapping location. Select the provenance graph location. Target T-box location. And target AVOX location. Yes, if all the inputs are given correct, correctly, the color of the operation will be changed. Now we can run it. The status of the ETL will be shown in the status bar. Here is the ETL of our use case. Once the target is generated, that is populated with ABOX and T. Here is our this is the ETL flow for our use case. Yeah. Now T-box user can create and run OLAP queries on their target using OLAP layer. A target can be accessed either from a local file or through an endpoint. Let's load our target from local file. We if input tbox and navboxes, it will take some time to load. As soon as the files are loaded, we can extract the cube structure from it. Cube structure contains dimension, corresponding hierarchies, and the levels of the hierarchies and measure. The user can create OLAP query to explore and aggregate measures at various level of details. Let's make a query. Here we have 3 dimensions: living position dimensions, geography dimensions, and residence dimension. The corresponding hierarchies are shown under as subnodes of dimension node. First, we want to roll off data from geography hierarchy administrative one level. When we select a level here, and the selection are shown in the rightmost panel, and yeah, let's add. We want to roll up data residence type level and living position all level inside. Then we can add measure. For example, we want to see addition and sum. Then we can create get result. Then it will give this result. So we can see here administrative level 1 level data and residence type rural and urban, and all living position all, and the summation, average and summation. You can click OK. For example, if you want to select one level some specific value, slice or dice 40, then we can get result. Now we can see that only value 60, 50, 60, 55 and 40 in that next level. In this way we can generate a complex OLAP query here by selection. So this is all from our site. Thank you for your concentration.